All right, let's jump into this. Unit 4.3, exponential functions is the topic. And you're going to see that several of these questions on this homework assignment are very straightforward. And what they're really trying to get you to understand is that when you're plugging in values into an exponential function. So let's think about this. So exponential function has the format of y is equal to a times, no, let's not even put the a on there. Let's just say b to the x. So the idea is here is that this could be written as f of x is equal to b to the x. And so the difference here is that these are exponential. But what we've done in the past is we've had linear. And in a linear function, it would be y equals x, and x was our actual base. We had quadratic, which was y equals x squared, and once again, x was the base. And then we go, cubic and quartic and et cetera, et cetera, et cetera. And so what we're trying to get you to see here, the difference in the behavior of the graph of a linear function from a quadratic function, from a cubic function, to an exponential function. And so we want to start seeing that how the behavior changes and how the graph grows differently than it would in one of the previous functions, one of the polynomial functions. And so what I want you to do is just take your calculator right now, and literally I just want you to plug this in your calculator. I want to make sure that we can plug in and see the relationship between these guys here, which all have a 2 in them and all have a 3 in the exponent, but how it's affected when you do a negative, or how it's affected when you do 1/2 to a negative, or 2 to a 1/3, and so forth. So take a minute, hit pause, go through, get those answers, come on back, and we'll pick up together. Okay, so I've gone through and I've answered the first 3 here, and these should be pretty straightforward. It's just a matter of putting in the calculator. However, you'll notice that I went a little bit further in depth in it. And let's remember what negative exponents mean. Negative exponents mean that we'll take something from being the numerator and move it to the denominator. So that becomes 1/8. Like I said, I asked you to plug this in the calculator. I didn't tell you to do it by hand, but I wanted to refresh your memory. On the next one, remember that in this case here, we essentially can distribute that -3 to both the numerator and the denominator. So we come out with this. We apply that negative exponent property, which says that this negative, you can move it to the numerator or denominator. So we move the denominator up to the numerator and the numerator down to the denominator, which makes our exponents positive. Now we simplify, we get 8/1, which goes to 8. Here, when we have 2 to the 1/3 power, remember this would be called, and we had an example of this would be exponential form, and this would be radical form. So we remember that these are actually synonymous to each other. So we have a couple ways to put that in our calculator. We could pull our calculator, we could say 2 to the 1/3, press enter, get a decimal. And go ahead and whenever you get a decimal like that, check to see if it actually comes out to be a fraction. So you can hit math, choose number 1, press enter, and you can see it doesn't. So we'll just call this 1.26 for the sake of discussion. Another way you could put this in your calculator is you could say 2, and then you could do your up exponent, and then you could do 1, grab your fraction key by hitting alpha y equals, and do your 3. So you can see that that's very similar. I just use parentheses on the last one. Or you could actually go ahead and just put it in as a radical like we have written right here when it's converted over. And so in this case here, we hit math. We would choose number 4. And then we can put our 2 inside, and we get the same answer. So a couple of different ways to look at that question. This next one has only one way of doing that. There's no need to convert that. I mean, yeah, we could, according to what I just said, is we could write this as 2 raised to the 3rd power raised to the 1/3 power, but that's unorthodox. We don't have a power raised to a power, so that's not really where we're going to go. So we'll just say 2 raised to. We'll grab our second square root. See our square root right there in blue. We'll hit 3, enter, and so in this case here, oh, and I told you, remember, always check for, see if it's a fraction. So hit math, choose number 1, enter. And so that doesn't change, so we'll call that 3.32. And then the last one, what I wanted to see is a comparison to remind you that if that is negative 2 raised to the third power, no matter what you do, you're going to get negative 8. Even if I did put it in parentheses and did negative 2 raised to the third power, I get negative 8. And that's been a topic of discussion, because if I did negative 2 raised to the second power versus negative 2 raised to the second power, this would give me a negative and this would give me a positive. But anytime we had something to an odd degree, 3, 5, 7, then basically you're telling yourself that you're going to take this thing and do it 3 times. So essentially on this problem, we're saying negative 2 times negative 2 times negative 2. So no matter what, we're going to get a negative. All right, so that's kind of run through in the basic concepts. I'm going to hit pause and make sure that's how I want to wrap up this first video. Yeah, so we'll wrap up that video like this. I just want to remind you that in your homework, what's going to happen is, let me pull up a homework problem in the background here. Let's say work as a student. In the homework, what you're going to see is that you're going to be doing like this, where they're going to give you a value to plug in, and you're just going to plug it in, and then they're going to tell you how to round it. So you're going to take 1.79, plug it in for x in your calculator, and you're going to round it in your thousands. So like I said, it's really getting you comfortable with what effect do different inputs have on the particular function or exponential function that we're looking at. All right, so good luck with those.